So today is lesson 5 drawings, and these are engineered drawings for everybody on YouTube over just what's normal, what's expected, understanding that normal isn't normal, it's just the most common stuff, and you're going to have all sorts of stuff thrown at you from random things that are requirements that may or probably won't be covered here. But generally speaking, this is what you're going to show on electrical drawings. And this is kind of a tongue-in-cheek meme or I don't know, drawing, I guess. I found it quite a few years ago, and it has always represented exactly how I feel about this industry. You know, this is what the owner wanted and or needed, and this is the process that we got here, and it just wound up being like garbage because there was lack of communication or understanding, or both. So try not to be this guy. So today, yeah, we're going to cover drawing sequences, what you should be doing to review your own drawings, or when you become a PE, what you should be doing to review your EIT's drawings, your drafter's drawings, or whatever. And then a quick topic over what our products and services look like. A list of the most common drawings in my personal order, because there's no requirement for order, is below. It's right here. Normally going to have, you know, the notes and then the note symbols, abbreviations, specifications, which I believe you understand the difference between book specs and sheet specs.
Yeah.
Okay, so for everybody on YouTube, you have sheet specs, which is a very high level form of instructions, written instructions to the contractor on, you know, 1 to typically 3 sheets of, you know, this is exactly the type of conduit that I want in this specific scenario. This is the type of insulation I want on conductors in these different types of scenarios. It's stuff that you can't show visually, but you still have to call out because of random things or because of requirements from the client or because contractors try to get away with stuff, which, you know, they're just trying to get in and get out and get on with the job. So you've got to make sure you can hold them to that. And specifications are legal requirements, so you can take them to the courtroom and say, look, you agreed to this. You have to do this no matter how much it costs you. So sometimes they show up on sheets, on like the actual sheets in the drawings, which are very high level. And then sometimes there's what's called book specs, which is, you know, the standard 8.5 by 11, nothing but words, nothing but text in that. You know, there's typically no pictures. The wastewater treatment plants I used to work on, you know, I would have 800 to 1,000 pages of book specs just for electrical. But of course, we were ranging everything from, you know, medium voltage underground to, you know, 4 to 20 milliamp on control systems. So, you know, 3 sheets to cover everything versus 1,000 pages to cover everything, obviously depending on what exactly you're looking for and what the job requires.
In the client, because like, correct me if I'm wrong, but don't some clients have their own specific specifications that need to be listed in the project? Like, for example, like mechanically, like, oh, they don't like using this specific pipe type for chilled water. They use this one over this. And like you put that in the spec because that is a standard for the client. Is that a correct statement?
That is a very accurate statement. And personally, I prefer when clients have their own standard, because what that means is I can copy and paste that PDF, that Word document, whatever, put it into our specs, whether book or sheet, and say, these are client requirements. My seal is no longer associated with these requirements. So if stupid stuff happens because they required it, it's on them. Now, yes, I will review them. I'll read them to make sure that it's not like,
That's me still meeting code.
Exactly. Yeah. If there's no life hazardous, you know, like something might blow up because they just don't know, or there was a problem on their end, yeah, I'm going to call them out and get clarification. No, if it's like, okay, you're reducing cost, but you're also reducing lifespan, and that is, you understand that, cool. Let's throw that in there. That's all you. You know, that's not the product I want to provide, but that's what you want, and so there we go. All right, so the next one is overall site plan, and this actually gets overlooked quite a bit. That's just the overall, you know what, I've been meaning to actually go through these. Sorry, apologies. Let me pull these up. So here's now I've got 3 random projects that I've kind of worked on. None of them are the same, by the way, literally. So here's the general notes that we were talking about. The abbreviations list normally looks like this, and then the symbols right here. Specification sheets. This is what sheet specs looks like. And for all of you that are like brand new to this industry, you will see, like in this case, let's go find a different one. Still tab. There we go. 260519. Like across the board, everybody understands the 0519 is generally associated with wiring connectors. Actually, like 0526 better. Like that's grounding across
And
the board.
26, section 26 is an electrical specification, like number of what I was told, right?
Yes, that is accurate. What is mechanical? I don't remember.
Oh my gosh, I just learned about this. I believe it's 22 and 20. I think there's like 2 or 3 of them. There's 22.
I've recently got into learning more about specs and writing them. So 22 to 24 or something like that. Oh, that's so bad. I should know that.
All right, so on your C drive, if you have Master Spec, which for everybody on YouTube, Master Spec is a spec editing software that plugs right into Word. You're going to have this in your address, okay? So everybody, so HVAC, yeah, so plumbing is 22, HVAC is 23, electrical is 26, and then sometimes we get into comm, which is 27, and sometimes into safety and security, which is 28. So these 3 are normally like electrical people, and these 3 are normally mechanical plumbing people. So any spec that you see start with, like in our case, 26, like that's an electrical spec, period. That's just how that works. And you can see how many specifications we actually have of different things we got to understand in and out, detailed what it requires. And I think mechanical is like pretty close behind us over what they are required to understand and fully vet out. So, so yes. There are 2 different types of numbering conventions, like one that was used up to like 2003, I think, 2006, somewhere around there, 2003. And then the new one that we're on, which is basically this, 2-digit, 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 so 6 digits total. Most people don't use the old one except unless you're military, which is a whole different story. All right, so that's specifications, and then number 4 was overall site plan. Let's see if I've got it in here. It's not 4. Yeah, it's not what I'm liking. Let's go home. There we go. Overall site plan. So this is a battery energy storage system I'm working on, actively working on. We're putting in a bunch of batteries here, stuff over here, existing stuff here. Yes, I have, individual sheets that show like nothing but this, and then nothing but this. But if they don't have an overall view of, okay, what does this entire site look like? It's just going to be a bunch of random lines going to each other, and they're not going to fully understand on the front end what all is happening unless you provide this for them. The reason I point that out is because what happens most of the time is when the general contractor, who's above all of them, gets the plans, the entire stack of plans, architectural, mechanical, electrical, plumbing, structural, civil, the whole 9 yards, what they do is they will go to the civil plans, rip them out, hand them to the civil contractor. Electrical plans, rip them out, hand them to the electrical contractor. So while, yes, in the entirety of the plan set, there's probably 5 or 6 or 7 overall site plans, and they probably look very similar to this. It doesn't mean your specific contractor is going to have an overall site plan, because most of the time, all they get is the electrical drawings in this case. So that's why I personally include an overall site plan to help them see, okay, what is the big picture 100,000 foot view that I'm looking at? I've been on the other side of that, trying to read drawings, trying to build things. And if it's not there, like you'll spend hours going through all the drawings going, I don't understand what these things are telling me, because I don't have the 100,000 foot view. It's kind of like the puzzles when we were kids, trying to put a 100-piece puzzle together, and you don't have the cover. You don't know what even you're looking at, and you eventually get it, but it's just a massive waste of time when you're charging people for that time too. So
is it Do you not recommend using a key plan as your overall plan? Because like I've seen on projects that we've done where like they're like kind of smaller projects where it's a big building and we're really only touching like a very small portion of it, where we'll just throw a key plan on the like the general like our first sheet in the corner and just show like, hey, this is the overall thing with something like that, but then have just instead of having the overall sheet plan too, we have that to cover our bases. Like, is that good enough in some situations? I'm not saying in every situation you should use a key plan, but does that work?
It totally works if you're working on, specifically a building and a specific part of the building. That's fine. Like in those cases, like this one doesn't even have an overall site plan, because what you're looking at right here is 400,000 square feet. Like there's no way I'm getting a practical overall site plan on one sheet that's going to say, hey, we got this one little dinky corner over here. And what you see here, like this isn't even the entire building. Like this is a massive manufacturing facility. I'm not doing that. Like, so yes, you're absolutely right. Key plan, just make sure it's accurate. Please make sure it's
And that
accurate.
it makes sense. It's like appropriate for the project.
Yes, exactly. Yep. Always make sure you know what there's there. Always make sure you've got the right blackout, essentially. So, as you can see, the differences between here, great. Here's an overall, and you can actually see what my next section is going to be, which is this square right here. That's what that is.
And that your key plan's not showing up on sheets it doesn't need to be on it.
Exactly. Yes, that's a good and valid point. Let's go take a peek if I have messed it up. Right there. Okay, so if your sheet plan's showing up right here, you probably don't need it there. I'd recommend taking it off. Excuse me. Okay. All right. So the next thing, we'll go over the next couple things together. And so you got power plans, lighting plans, and then special systems plans. Now, depending on the size of the project, you can combine some or all of these. Like if you are literally installing a door and moving a light, like a project I pushed out 3 weeks ago, we installed a door in a hospital. I don't need 3 different sheets to go move the light, move the little key card thing, and move this receptacle. Threw it all on one page, done. I am not making 3 different pages for that. It's just asinine. No, combine them. Just combine them. But if it gets to the point where it's too tight, too much information, too much stuff on the same page, that's when you start breaking it out. So prime example, like this is a power page. This is existing building that we were renovating. This, it's fairly busy. It's not incredibly bad, but if I were to combine this page with this page, no, that's too much.
That would be
Break it
a
out.
mess.
Exactly. Yes. However, on here, I'm also showing special systems, card readers. And I did actually have them broken out at one point in time, but when I looked at the overall special systems sheet, it literally just had card readers on there. It was all white with like a few black boxes. I was like, okay, this is dumb. I'm not doing that. So I combined them.
So
And then-
this is sorry to cut you off.
No, please.
Just from looking at it, like, so this is the power plan. You're showing the circuit, like what you're circuiting together, and then the little arrow popping off of one end. That's called a home. Is that called a home run?
That is called a home run.
Okay, so like pretty much what it's doing is saying like, hey, all of these are connected in one circuit, connected to one breaker on like, so breaker 31 on LDP1, which is like the panel.
Yes.
That's what that means? Okay. And these
That
are
is-
just receptacles, right?
Yes. Yeah. What you're seeing is different types of receptacles.
Ground fault receptacle. I don't know what TR means, but
Temper resistant. So it's making it to where like a little kid can't shove a toy or something in there.
gotcha. Okay.
Um,
But that's what the power plan is. It's showing how you're circuiting everything on your plans.
Exactly.
Okay.
You can do that one of 3 ways. You can do the home run, which is the most common, especially with the
Get
smaller
it to where it
circuits.
needs to go.
Exactly. In North Carolina, apparently, you can just stick this information right in front of whatever disconnect. This is a recirc pump, and this is the disconnect for the recirc pump. Apparently, you can do that. You cannot do that in other locations. And then you can also keynote it. Like if it's just too tight, too much, and it ain't gonna work. One of the stuff I've seen is, assume this keynote just moves right here in front of this arrow, or even right in front of the J box if it's just getting too much, and then you could, I've got them covered up, but in your
Just have
keynotes over
your-
here,
Gotcha.
yeah, circuit, whatever that is, RCP1 to LDP 1-42.
Just keynote where everything's going.
Yes. And that was actually very common in like the water, wastewater world, because you would have, 25, 30 things along this line that hardly pulled any power, but I'm not going to make 50 individual call outs for 50 different rooms. No, just keynote the dog out of it and go forth. Because you can also add additional keynotes in there, like, the type of wire, or if you needed to add special instructions. So.
Electrical done on like water, wastewater plants, like is very like those drawings, at least in how our company does things. I don't know if it's like across the board that way, but like their drawings are very detailed. And then for more of the MEP style work is more of a like schematic almost. Is that correct? Like we are more like this is how you can do it, but like for like those water wastewater plants that I've seen drawings on, it's like it's very detailed, and it's like what's on the drawings is what's getting ordered. What's on the drawings is the way it's going to be done. I'm not saying ours are more like a suggestion, but like that this is a way to do it. Is that correct? Or wrong?
No, you're not wrong. So let me summarize for the people on YouTube what she's kind of talking about here in a more simplistic term, and then relate it to the water, wastewater world. All right. So when it comes to lighting, there's a prescriptive way to do it according to IES. I don't know, one of the lighting requirements. It's been a while since I've actually even looked at it. You can do things like occupancy sensors, or you can do things like timers, or you can do things like time of day timers. It's going to be on from 8 a.m. to 5 p.m. Any time outside of this, it's going to be off unless you override it. Stuff like that. There are also proprietary lighting systems for each manufacturer. Now, yes, I have actually done this of going, I know this manufacturer, the client wants this manufacturer, but since they're a public entity, they have to have 3. I'm going to design it according to this proprietary information. Note that, acceptable alternative design, or alternative designs are acceptable. Contractor shall submit during bidding or whatever. Basically saying, here's a one-person bid item. If you got a better design, let me see it. Otherwise, here's something that nobody else can do. So that's the more detailed concept of here's something nobody else can do versus like what you're seeing here of I threw in a bunch of aux sensors. Anybody can do this. Go forth to any of the manufacturers. When it comes to the water wastewater world, there are some things that have to be manufacturer specific just because of the overall concept of how they're cleaning the water, whether it's, wastewater coming in to go into a stream when it's done, or groundwater coming in to go into the faucet when it's done. There's all sorts of different ways that need to be clean, and there's only a limited amount of manufacturers out there. Between the power requirements and primarily the signal requirements from the electrical side of things, one manufacturer may scrub that water in an entirely different way than another, and there's no other options. So there's 2 design approaches. You can say, okay, manufacturer 1, I've designed around you. Manufacturer 2 is acceptable, but the contractor's got to give me a design to approve. Or you can do the most overall, like, okay, both manufacturers, of the 2 manufacturers, this piece of machinery requires at most 20 signals. So if the one that has less signals, well, great, we've just got a bunch of extra conductors installed, go for it. It's basically a worst case scenario design. When you don't have somebody specific in mind, it costs the client more. When you're designing to somebody specific, it is much cheaper and easier on the client, but it does cause other issues on the backside. Does that answer your question very long-windedly?
No, yeah, that makes sense.
Yeah. And I hate not being simple in my answers, but it is very complicated. And don't forget your lighting fixture schedule, by the way.
What was that?
I said, don't forget your lighting fixture schedule, by the way.
Do you typically put your lighting fixture schedule on the lighting drawings, or do you put it on like the schedule sheet? Depends.
With the newer Revit versions coming out, you can actually do both now. Before that, you couldn't put the same schedule on two locations. So it always went on the lighting schedule. When I was doing this stuff, I hated having one finger on like the front end of the documents and then one finger in the very back end of the documents, because light's usually in the end, and trying to sit there and flip back and forth. Okay, what was an A fixture? Flip, flip, flip. What was a B fixture? Flip, flip, flip. Ah, crap. What was the difference between a B and a BE? And just flipping back and forth. Instead, when you're in the field, you're going to look B. Great. There's all the information I need. Drove me nuts trying to do that. So yes, please put it on the drawings, on the actual lighting drawings. I'm asking you. Please do that.
Like you're doing it do it for you too.
Yes. Your contractor will like you much better. All right, so the next thing we were looking at, so we went through power plans, lighting plans, special system plans, very high level. Riser diagram. Let's go take a peek at that, because you and I had discussed the differences between a riser and a single line. Let's see if I can pull up the differences. Hold on. All right. Okay, so this is a riser diagram. This is showing like how things are connected from this is 3 levels. This is that very large manufacturing facility, by the way. Generally speaking, how is this stuff connected? Doesn't have a whole lot of information on it other than a roadmap of how it's doing, how it's connected. Riser diagram. Single line diagram is much different. Single line diagram looks like this. There we go. Okay. And yes, like I said, this is still in production. It is showing conductor sizes. It's showing overcurrent protection. It's showing, relays and whatnot. It's showing the basic concept of this is how you size what, where, when, and why. Okay. Very similar to the concept of the overall site plan versus like just a power site plan. Like this is a power site plan. This is an overall site plan, but from an electrical standpoint, like an electricity standpoint.
And is it, yeah, no, that makes sense. Is it a good way to like put it that the riser diagram is like how, like you said, how the big equipment is wired up, like meaning like what's attached to what, but then the single line are the details of like you said, like the wire size of panel going to transformer, like these specific, it's like more detail of this. Is that a good way to put, like, that's kind of what it seems like this is just like, hey, this piece of equipment is connected over here. And then the other one's saying like the wire size for this equipment to go here is this, and it looks like this.
Exactly. And that is a very accurate understanding. That is exactly how that works. Sometimes you can do the let's say the detailed information on a riser if the riser's fairly small. I don't know if I've got I didn't even do a riser on the other one. Sometimes you can combine it all into one, which I've done, which is fine because it was like this big and like that was it. Okay, great. I'm not going to do a single line in a riser when I've got like 4 or 5 panels. Just throw it all on one and be done. But when you have, this many panels, switchboards, ATSs, and when you have this much intricate wiring, because these are two different projects, remember, that requires two different concepts.
Gotcha.
All right, so let's go to panel schedules. All right, so panel schedules. In your panel schedule, there are several things that you're looking for. You always want to have the location where you're being supplied from. Mounting is not that big of a deal. Surface means like it's just stuck on a wall, and recess means it's stuck inside a wall. Type 1, that's the NEMA enclosure rating, meaning, can this handle an accidental spray from a water hose, or is this like you touch me with water and you're going to die type thing? Obviously, we've covered this in previous lessons. Are you familiar with what AIC rating is?
AIC rating. No.
Okay, ampere interrupting capacity is the actual AIC. All right, so if I have, let's say I've got the panel board open. Let's say I've got a very large switchboard open because it's easier. And I've got a very large wrench in there because I'm trying to tighten a nut. And I drop this wrench and it lands on all three bus bars, and there's a massive amount of current flowing because it's a very large wrench, right? Like, this is the most amount of current I can pull out of this system. I've still got to be able to open, breaker. I've still got to break the circuit depending on how much current can flow in that scenario. It's called a bolted fault. If I've got too much current flowing, like if I've got 40,000 I've got a 40,000 AIC rating on my entire system, and my breaker's only rated for 10,000 AIC, then if this bolted fault happens, even though I open my breaker, that current's still going to flow. It can melt the breaker, it can jump the gap, it can do half a dozen other things, or it can just straight up blow, like explode with massive amount of force. So when there's a bolted fault, I have to still be able to open it. That's the AIC rating. Does that make sense?
Yeah.
Okay. All right. So MCB's main circuit breaker, mains rating is how much your bus bars can handle, and your main circuit breaker rating is how big. You can have like a 400 amp MCB on a 600 amp panel board. That's fine. 500 amp MCB on a 600 amp panel board. That's fine. Like, there's nothing wrong with that. Just you're setting your MCB rating at what you're supposed to per NEC, and your mains rating at what you're supposed to per NEC, and those can be two different settings, or two different ratings. Next. All right, so this is a Revit native panel board schedule. Where we work, we have added additional things like conductor size, conduit size, stuff like that. We've added columns here to put on all that information. It's really cool. It's a lot of complex programming relative. And I've got that if you ever need it, by the way. Okay. But this is a basic one, and I kind of liked it. We've covered all this, the trip rating, the poles, the VA, like that's all previous things. This is obviously a 3-pole circuit because it's covering 3 circuits, so on and so forth. One of the things that you need to understand, so actually we'll stick with right here. All right, so you can have unbalanced load, right? The final number here was a total connected load, 383,133. That's just adding up all of these, and then the connected current is dividing by √3 divided by 480. So this 461 is basically, if you want to call it, the average of these of these 3 individual bus bars. However, if I were to add all my large loads on phase A only, I could have 800 amps here, 100 amps here and 100 amps here and still be under my 600 amp mains rating, technically, mathematically. However, I've got 800 amps being pulled on phase A. I'm going to blow up. I'm going to melt my copper bus bar in there. So while, yes, this is a good number to look at, always do a gut check over if these three numbers are over their individual bus ratings, because this bus is rated at 600, 600, and 600.
Yeah.
And yes, that has happened both from a panel schedule perspective, design perspective, and in the real world. And when it happens in the real world, that's a bad day. Seen that.
Why in the like in the TX LDP, the 3-pole, the one at the very top, how come the volt amperage is all different? It seems like every other one, like the 3-phase, it was all the same per bus, but that one's not. Is there why? I guess was my question.
It's a good question. So
Every other
TX,
one isn't.
yeah, they're not all even. Like RTU is 11362, 11362, 11362. So TX stands for transformer. That transformer LDP is actually feeding LDP1. So if you look here, you've got 18520 and 18880. 18520, 18880. And of course,
Okay.
obviously that's going to match too.
Gotcha.
That's why. It's a great
Okay.
question. So and that's a trick, if you've got too much current on phase A, and you're like, hey, I can move this off because I'm really low on C phase. Instead of moving stuff around here, come down here and move it because this is all single phase loads.
Gotcha.
So yeah. I don't know what else. See any massive examples. All right. So the next thing is load classifications.
Will you only see that with transformers?
Well, you can also have subpanels. Like,
Okay.
for instance, HM1 has. Oh, well, okay. So if HM1 didn't have nothing but 3-phase loads on it, then HM1 would be.
In the
I would
same
expect
boat.
it to be. Yeah, I would expect it
Okay.
to be different.
Okay.
Generally speaking, the answer to your question is, if you've got a 3-phase load, like a single point load, like an RTU electric water heater, yes, you can assume those are all going to be even. If you were to go out there and physically measure it, no, probably not. But there's no way we can figure that out, without having measured it. So just throw it in there, split across the 3, and be done with it. On load classifications, okay, where we work, our Revit people have preset load classifications. I personally disagree with them. I professionally disagree with them for a multitude of reasons, but I don't have enough swing in the Revit world to be able to say you're wrong, we need to fix this. On top of, if the way I did it is incredibly convoluted and complex because I followed the NEC to the letter, like to the T, and I've got a ridiculous amount of load classifications because that's how they did their load calcs in the front end of the book. I'd have to remember where it was. 220. There we go. In Article 220, it tells you how to, come up with the final number of your service.
And this is like the demand factor is like putting diversity to like your panel.
Exactly. It's exactly
Okay.
what it is. Receptacles, for example, the first 10,000 VA you're supposed to take at 100%. So this will say 10,000 VA, and then everything else after 10,000 VA you can take it. I think it's like 50% or 80% or something like that. I don't remember. So that's where this random 59.39% comes from. Well, Revit does its own math internally, which is really awesome, by the way, and then spits out this number. And the reason for that is because you're not going to have every single receptacle pulling an amp and a half all the time. That's just not how that works. That's why the NEC fully understands, just derate this on this is generally how it works. We're swinging for the fences regardless. Just do it like this. The same token, HVAC. Okay, so most of like the RTUs and HVAC units, we'll do residential, for instance, because it's easiest. In your house, you have both a heater, an electric heater, most likely in your air conditioner, and an actual air conditioner. 99.9% of the time, the heater is going to pull more than the air conditioner when it's operating. You don't have to account for both the air conditioner and the heater loads because you can't run both at the same time.
Gotcha.
So you find the larger of the two and use that in your panel schedule. That's how that's supposed to work per NEC, but in our company, it's just like HVAC, go forth.
100%.
Yeah, 100%. You're supposed to do this. Like that's, yeah. Same thing with like the lighting. There's been a lot of conversation over, is lighting considered a constant load, which is 3 hours or more per NEC. If it is, you're supposed to have a demand factor of 125%. Well, I have problems calling a lighting a constant load because, well, yes, it is technically a constant load by definition. It's not going to have the same effect as what another constant load consideration would have on heating of the conductors, on this, on that. Like, there's a lot of other considerations. I
It's just
personally
not
don't.
the same.
It's not the same, and I have not found anything outside of the definition, the generalistic definition of constant load, to say yes, lighting should be also considered under this. So that's the demand factors. If and when you ever get into this, feel free to call. I'll walk you through half a dozen other things.
Okay.
Okay, that's panel schedules, and then any questions on that?
I don't think so.
All right, and we'll quickly move on
Cool.
to details.
How much do you have left?
Not actually quite a bit. So let me. Yeah, I mean.
Is it a good
Okay.
stopping point?
Yeah, I was about to say, let me cover details, and then in our
Okay.
next video, we'll do the list of common drawing review practices. Because
Okay.
this, you definitely, like, you need time for this. You need that.
Okay.
So when it comes to details, most of our details are copy and paste across the board because they've been vetted, they've been used for years and years and years and years. Like, most of them are acceptable. These are about the only details I can find at the moment. But when you go to put these in, make sure you actually need the detail and make sure the detail is still accurate for what you're trying to do. It doesn't matter if these have been used for the last 25, 30 years. There's still all sorts of random stuff that can be poking out that, one, nobody's ever caught, two, nobody's ever questioned, or three, is no longer available. I came across a detail not too long ago that was requiring triplicate paper submittal for how it was installed. Like, do you know what triplicate paper is?
Mm-mm.
Okay. I'm sure you do, you just probably don't realize it. So think of
yeah.
probably before your time, you've seen where there was a white sheet with a yellow sheet behind it with a pink sheet behind that. And when you wrote on one, it showed through on all three.
Oh, yeah, I know what that is.
Yeah.
Didn't know that's what I'm not lying in my head. It's just not what I was thinking that was.
Yeah. And most people are like, oh yeah, I remember seeing that from the movies from the 80s. That's when
Oh,
it
I
was
remember
used
that
last,
from
was
school.
the 80s.
Well, I
Oh,
remember
really?
that
Okay.
from school. Yeah, there's certain things for school, and then working in a restaurant, there's certain things that you have to give to the bank, and you use that type of paper to have like your copy, the bank's copy,
Okay.
and then like a other copy, I guess you could say, for like record.
Yep. Okay.
So yeah, I've used it before.
Gotcha. Okay. We don't use triplicate anymore. We use PDFs. Like, that's like, no. And that detail had gone out on hundreds of projects, like hundreds of them. I'm like, this isn't right. And same thing with the specs, by the way, because I found a spec the other day that had just gone out on somebody else's project that required submittals on a 3.5-inch floppy. No, like I can't even read a 3.5-inch floppy, and this is legal requirements, so I could technically hold them to that. But no, that's just asinine. Read your
The funny
details.
thing is how many contractors are going to even see that and like make a comment of it and be like, hey, yeah, no.
Well, and that's a great,
It's
honestly,
how little like specs are actually read, honestly,
yes.
of how I've seen. It's like I've kind of been told recently, like if it's something super, super important, put it on the drawings. And then I was told that, yes, if there is some discrepancy between what the drawings are saying or what the spec's saying, at least it's going to get addressed rather than it just being put in the spec and then never addressed at all. Like you'd rather at least get a comment on it or like it get addressed, period, rather than just, yeah, we're going to put it here and it's like a cover our ass. Like, yeah, it's okay because it's in the spec, but who knows it's actually going to make it like when it's actually done. I don't
Yeah.
know if you agree with that, but like that's what I've heard recently. Like if it's really, really important, make sure it's on the drawings.
Yes. So my delineation point is life safety on the drawings, like somewhere on the drawings, life safety. If it's, monetary value, okay, it depends on how much. But if it's something minor, great, whatever, that's fine. Um, I'm about to wrap up, but I did want to let you know if you ever need like a mind rest but still learning, go to YouTube at some point in time, and I think it's David Lee Roth talks about no brown M&Ms. I want to say he was part of the Van Halen group, or like the rocker band Van Halen.
Hmm.
Um, in their in their specs, because that's how that works. Hey, we need this many elements. We need this. We need that. They required a bowl of M&Ms with no brown M&Ms in it, or something like that. I know I won't spoil it for you, but go watch the video. Incredibly helpful in our world, even though it's coming from I'm sure a rocker with a lot of great stories. We'll put it like that. But it definitely helps. So, um, do you have any questions for me over anything we've covered on lesson 5? We'll call it 5.1.
Not right now.
Okay. Well, if you think of anything,
I
no.
think, yeah, I think more of the questions that I'm gonna have like from this first like half of the lesson is, um, like I've seen all those things and like maybe I didn't know that there was the three specific type of plans, but like more on the actual plans themselves, like what certain things are, I think is more of going to be a lot of my questions. Like seeing the power plan, like I'm like I had a general idea of what it was and what it was doing, but I guess it's knowing the little nitty-gritty things about it that I obviously probably have not seen
Oh,
and maybe
okay.
don't understand.
Well, if that's the case on 5.2, we can go further into depth on details in all of these. I
Yeah.
was trying to go through very fairly quickly just because of
Yeah.
the time constraint.
Hmm.
But no, if 5.2 needs to be a more in-depth recap of this, that's totally
Hmm.
fine. And then we can make this like a 5.3 if we needed to.